Hi everyone, welcome back to my channel. Today we will learn about an interesting topic. Magnets, have you heard about them? Before, let's dive in and have some fun with magnets. Last evening I was playing with my brother in the garden. After playing for a while, my brother got bored and started to search around. He found a U-shaped object but didn't know what it was. He bought it to me.
Sister, look what I found! What is this? It looks funny.
Oh, that's a magnet. You've just discovered something amazing, brother.
Magnet? What's that?
A magnet is something very special. It can pull things towards it, but not everything. Mostly metal things like iron.
Whoa, it grabbed the nail. How did it do that? Is the magnet magic?
It does seem like magic, doesn't it? But it's actually science. The magnet has something called a magnetic field. It's invisible, but it's all around the magnet, pulling things made of iron, nickel, and cobalt towards it.
So, it's like the magnet has invisible arms?
Yes, kind of like invisible arms that can grab only certain things. But not everything,
Why doesn't it grab the leaf?
because the leaf isn't made of metal. Magnets only pull things made of certain metals, like iron. But guess what? Magnets weren't always understood. Long ago, people didn't know what magnets were.
Really? What did they think it was?
A long time ago in ancient Greece, people found strange rocks that could attract metal. They were found in a place called Magnesia, which is why we call them magnets today. At first, people thought these rocks were magical. Later, they realized it was a natural force.
So the Earth has magic rocks too.
Sort of. The Earth itself is like a giant magnet. That's why compasses work. They point north because of the Earth's magnetic field. Sailors used magnets to find their way when they were lost at sea.
So magnets help people find things too.
Yes. They help in many ways. Magnets are in all sorts of things. Televisions, computers, even the fridge at home. That's why you can stick things to it.
I want to find more magnets. Maybe I'll find a super magnet that can grab everything.
That would be something. But remember, even super magnets have limits. They only pull what they're meant to pull, just like how some things in life are meant for us, and others aren't.
I get it now. Magnets are strong, but they follow their own rules.
Exactly. Just like how we can be strong and smart but still follow rules. And that's the science of magnets.
How do you know so much about magnets?
Our teacher taught us about it in school last week. Do you want to know more about magnets?
Yes, please tell me.
Okay, listen attentively then.
Magnets have become very common these days. Have you noticed that if you leave the door of a refrigerator slightly open, it shuts automatically? It happens because the refrigerator door has a magnet fixed inside its rim. Magnetic stickers, refrigerator and almirah doors, toys, and pin holders all have magnets fitted inside them. The phenomenon in which materials exert attractive or repulsive forces on other materials is known as magnetism. The history of observing the phenomenon of magnetism goes back to 600 BCE, when the Greeks found a certain type of stone that had the power of attracting a piece of iron. Thales, the Greek philosopher, made the scientific discussion about magnetism. About 2800 years ago, a shepherd named Magnes lived in a town called Magnesia in Greece. He used to take his herd of sheep and goats to the nearby mountains for grazing. He used to carry a stick which had an iron tip. One day, while his cattle was grazing, he sat down on a blackish rock to take some rest. While getting up, he noticed that the iron tip of the stick touched the stone and got strongly attracted to it. The stone was a natural magnet. It became the first magnet to be discovered by a human being. Probably based on the name of that shepherd, the rock was given the name magnetite. The word magnet is derived from the name of the town Magnesia. Magnetite mainly consists of a chemical compound, iron oxide. It was also found that if a piece of that stone, magnetite, was suspended freely, it always came to rest pointing along the north south direction. This property of the stone was found to be of great help in determining directions. Hence, it was called lodestone, which means leading stone, as it was used for leading or directing people. During the 12th century, the Chinese used lodestone as a compass for navigation. The force that the magnet exerts on magnetic substances such as iron, cobalt, and nickel is called magnetic force. A magnet has the ability to pull or attract objects made of iron even from a distance. Therefore, a magnetic force acts from a distance even when there is no direct contact between the objects. A magnet possesses two essential properties. It attracts small pieces of iron, cobalt, and nickel towards itself. It always comes to rest in the north south direction when suspended freely. A magnet that occurs naturally and is not made by any artificial means is called a natural magnet. Lodestone and magnetite are natural magnets because they are found in nature. Magnetite is an ore of iron. These natural magnets have low magnetic power. At the same time, such magnets are found at very few places. Natural magnets cannot be used for any useful purpose. A substance to which properties of the natural magnet have been imparted by some artificial methods is called an artificial magnet. Such magnets are made from iron, steel, cobalt, or nickel. Artificial magnets are made in different shapes. They may be flat bars, cylindrical, dumbbell, or U shaped like a horseshoe. All the magnets that we see in our daily life are actually artificial magnets. These magnets have high magnetic power. The substance that is strongly attracted by a magnet or can be artificially converted into a magnet is called a magnetic substance. For example, iron, cobalt, nickel, or other alloys of iron and magnetic substances. Ferrofluid is a unique material that acts like a magnetic solid and a liquid. It contains microscopical tiny particles of magnetite suspended in a liquid. A ferrofluid is used in computer hardware and in medicine. There are two types of magnets, temporary and permanent. Temporary magnets retain their magnetic properties only for a short period of time. On the other hand, permanent magnets retain their magnetic properties for a longer period of time. Temporary magnets are usually made of iron, cobalt, or nickel. Permanent magnets are prepared from mixtures of iron, cobalt, or nickel with other elements. The ends of a magnet are called the poles of the magnet. Each magnet has two poles, the north pole and the south pole, at opposite ends. The magnetic force is maximum at the poles of a magnet. A magnet always points in the north south direction when suspended freely. The end of the magnet that points towards the north is called the north pole. and the other end of the magnet pointing towards the south is called the south pole. It must be remembered that the north pole of the magnet gets attracted to the south pole of the Earth's magnetic field, and the south pole of the magnet gets attracted to the north pole of the Earth's magnetic field. Like poles repel, unlike poles attract. If a bar magnet is broken into two pieces, you will see that each piece behaves as a whole magnet. This shows that new poles are formed at the broken ends. If these pieces are broken again, each of the smaller pieces behaves as a whole magnet with the two opposite poles. We therefore conclude that the poles of a magnet cannot be separated. Magnetic poles always exists in pairs. That is why a magnet is also called a dipole. If we are given a metal bar and are asked to determine whether it is a magnet, how will we find out? For this, we need a bar magnet with both the poles clearly marked. We shall bring one pole of the bar magnet near both the ends of the metal bar, one at a time. If one end of the metal bar is attracted to the magnet and the other end is repelled, the metal bar is a magnet. If both the ends are attracted to the magnet, then the metal bar is not a magnet. It is just a magnetic substance. Thus, we see that repulsion and not attraction is the surest test for magnetism. The area around a magnet up to which it can attract very fine magnetic substances is called the magnet's magnetic field. It has a fixed pattern. A magnetic field is strongest at the poles of the magnet. A magnet train floats on a magnetic field. It follows guidance tracks with magnets. These trains are often referred to as magnetically levitated trains or maglevs. A maglev train floats about 10 millimeters above the guideway on a magnetic field. Electromagnets run the length of the guideway. Let us understand how to convert an iron bar into a magnet. The iron bar which is to be magnetized is kept on a table. A strong bar magnet is held nearly vertically with one of its poles, touching one end of the iron bar. The magnet is moved along the length of the iron bar to the other end. It is then raised and brought back to the starting position. The process is repeated about 30 to 40 times, moving the magnet always in the same direction. The iron bar is then turned upside down and treated similarly. The iron bar is then tested by bringing it near to some iron flings. If the iron bar attracts the iron flings, it shows that it has been magnetized. Thus, the iron bar becomes a magnet. The starting point acquires the same polarity as the polarity of the magnet which was touched and moved over it. This method of making a magnet is called single touch method or stroking method. Magnets have a tendency to lose their magnetic property or demagnetize if they are not properly taken care of. They lose magnetism if they are heated, hammered, or dropped from a height. Even when the two poles of a magnet are left free for a long time, the magnet loses its magnetism. The process is known as self demagnetization. To keep them safe, they are kept in magnetic keepers. Magnetic keepers are pieces of soft iron that are placed across both the poles of a bar magnet or horseshoe magnet. The bar magnets are kept in pairs with the unlike poles along the sides and separated by a piece of wood. Magnets need to be kept at a distance from some objects with magnetic components, such as cell phones, television sets, cassettes, computers, and compact discs. A magnetic compass is a simple device which has a magnetic needle free to rotate on a pivot at the center of a round box. It is used by sailors and navigators to know the directions. In the magnetic compass, the needle which is free to rotate always resets in the north south direction. Magnets are used in our day to day lives. Some of these are given below. Cranes carry a huge magnet to remove iron items from scraps in a junkyard. Computer hard disks and audio videos cassettes and have magnetic material that store information. Plastic cards have a strip of magnetic material that stores information. Doctors use a magnet to remove metal pieces from the eye. Magnetic toys, speakers, pencil boxes, refrigerators, and many other things have magnets in them.
Wow, that was some interesting information. I learned a lot about magnets today. I didn't know that there are so many interesting things we can learn while playing, also. Thank you very much, sister.
You're welcome, brother. I also enjoyed teaching you about magnets today. It was fun. Tomorrow I will teach you something new and interesting. I hope you all liked today's video. I will try to make more such videos for you in future also. If you liked the content, please subscribe the channel, share with your friends, and hit the like button.